Alright, so welcome back again. So in the previous tutorial we saw how to implement our own map function, right? That is what we saw earlier on in the previous tutorial. Now let's see how to implement our own zip function. So as you already know, as we did earlier on, if I go with import built-ins and I just do dir built-ins, you can see that zip is part of the inbuilt functions of Python, which is very useful and very powerful, right? That is the last one here, right? Zip. Perfect. So how do you implement your own zip, right? So zip is very useful for a lot of things, just like a zip. So in case I have some numbers, so I have some details, so I have first names, so say F names of some people. So let's say the name is Jesse, everybody likes his name. Another name like, let's say Mark. Another name like Avra, yeah. Another name like let's say any name, so Edu or Kofi, something like that, right? These are, let's say these are all first names, and I also have some last names, and then I want to put them together. So TP, that's my surname. The Mark is, let's say Mark Peterson. Say we have sign, something like that, and then let's say this is Asamoah, right? Some normal names, right? I have these names and I want to map them together, right? So how do I do that? I want to put them together at the time. So the simplest way is that you can just loop through them, but using zip it becomes easy. So with zip you can just do like this. So I can just have my name, so zip, right? That is the default option. So I have my zip, then I'll pass in the F name and then the last name. So if I go with this option and I run it, now it's automatically going to give us a generator of object, which is in the format of a zip. And in case I want to get all the values, I can just go with list. If I go with list now, I'm going to get everything back, right? So Jesse Agbe has been paired well, Mark Peterson, Avra signed, Kofi Asamoah, right? Very nice. So that is the concept of zip. Zip is very useful in case you want to do some paralleling stuff, right? To combine two things together. This same thing can be used to do a dictionary. So in case I want to do a dictionary with this, so with a dictionary, so create a dictionary from to list, right? So or from to list, I can just do the same thing with this. Now pass in this one here. If I pass in here without the list, it's now going to convert the entire stuff into a very nice dictionary. Because that is a nice dictionary with our names there, right? Very nice. So that is some of the cool features of zip. Now how do you implement your own zip? So let's see how to implement our own zip from scratch. So as you can see, it is checking the number of the length of each list, right? So let's give another list. So let's call this one as to say salary. Let's give it let's put a salary and let's put in some numbers there. So 1,000, something like, let's say 40,000, something like, just different numbers. Then another number. If you look at these values here, right, we can actually use the same thing. We can combine not just two lists, we can also combine three. That is the advantage of using lists. So we can combine three. So combine three. So in that case, it's going to be the same thing we did. And now I can just put in the salary there. And it's also going to work and give us the result. But as you can see, the last value 1, 2, 3. This one has 5 values. The other one has 4. But with zip, it ignores the other one, right? So it ignored the last one, 6,000. That's why we couldn't see it here. So how do you? That means that it's considering the length, right? So it's going to pick the shortest length among them, not the longest, the shortest length. So if this one was, if this is, let's say, let's add another name like Fifi, right? I have no name, and let's make this one like another value, so 7,000. So you see that this one is 4, this is 5, this is 6. But if I run it, it's going to pick the least number, which is 4, the 4 one, right? It's not going to pick the last one. It's not going to pick these ones to pick the least, right? It's always taking the shortest. If I go with this one, it's always picking the shortest. If this is taken off, if I take off the coffee, right, and I run it again, it's going to take the shortest. It's always taking the shortest, right, as you can see from here. So that is the basic understanding behind working with zip, right? Very nice, except you use longest, which you will learn that one later. Okay, so let's see how to implement our own zip function that accepts all of these options, right? So the first one that is going to be our own method, so implementation. This is going to be method number 1. So as you have seen, it takes into consideration the minimum length, right? That is something very, very important. So it's taking the minimum length there. Then the next thing is that it's going to make sure that it's going to strip off everything into a tuple. So it's going to isolate, or let's say isolate each element, right? And then it's going to now loop through them, loop and then pair them, right? That's the basic understanding behind it. So let's write a simple function to help us do that. So the simplest approach is just go with this option. So I'll write the simplest one, then we move on to a more complicated option. So it's going to be this. So we want a minimum length, so let's call this def my zip, right? My zip I'm creating. Then this is going to take in some sequence, so let's use asterisk sequence, right? Then from there I can say that, okay, I want my minimum length, because that's the first method, so I want to get the minimum length. And the simplest way of getting the minimum length is just to loop through the entire stuff. So we have my length, so the length of every sequence, so this for s in that sequence that we have, right? That's a basic understanding. And we want to get the minimum length, you just use the normal length of this. So this one is going to give us the minimum length that we have for all the sequence that we have. So if you have 1,000 sequence and the rest is going to give us that particular, the minimum length of the minimum of every sequence, right? So it's going to pick all the sequences and then give us the minimum length, right? The one with the least number. Then after that we can loop through them. So that's the second thing. So I'm going to isolate each of them by looping through them. So for I in the range of that particular minimum length that we have, I want you to do something. So I want you to loop through it and give us my result. So the simplest way that I can just put this thing here, I can now come back to, you can just use a tuple, right, if you want. So for I in this, I can just come back here and just do this option here. So let's say, so tuple, so let's put the entire stuff, so return my tuple. We're going to return a tuple so that we don't change it. So it's going to be my tuple, so tuple, right? Then I'm going to say, okay, get that particular value that we have, the particular element, because you're isolating each element. Then you're going to pair it with what we have in the sequence. So that is a simple implementation of it. So this is my implementation. So let's see if it works. So what we are doing is that we're getting a minimum length. Then you're going to isolate each element right here and then loop through them and pair them, right? So let's run it and see if it's going to work. So now I have my odd number, I have my name, so zip, we have these values there, the first name and last name. So let's try it and see if it's going to work. So we have my first name and then my last names. So let's run it and see. Perfect. So it worked perfectly, right? So it worked and gave us the minimum length. So JCharisTech, right? Very nice. So the reason it's giving us this option here is because of where we put the return. So if I bring the return in a different place, or if I put the return in a list format or in a better format, it's going to give us a better result, right? So let's do that for that. So let me create a list at the top here. So let's go, that's my result, right? And I'm going to append this one into that particular one. So now let's create a list and put them there. So I'm going to create my result. So we did earlier on. I'm going to append this one to that particular result. So it's going to be append. So my result dot append. I'm going to pass in this particular value. So in case you have any question or contribution, you can put it inside the comment section below. So result. And now let's run it again. If I run it, I'm going to have a list with them there. So that is how to implement your own custom zip, right? So it works perfectly well. So it's picking the minimum length. So if I go back again and then let's do the same thing for one with longer length than the other. So let's do the same thing for the names. Let's go with the salary. Since it's picking the minimum length, it's going to just do for the 3 of them, right? The one with the minimum len. Very nice. And let's try it with 3. So we combine 3. So combine 3. I want to make sure that our function is working. So we'll be combining the 3 of them. So this, let's add salary to it. And it works, right? So it works for all of them. So this is a very nice implementation of our zip function, right? It works perfectly well. But we can make this one better, right? We can actually make this one better by putting this one here. This works perfectly well. If I check for the time it, so let's time it and see. If I check it out, we can make it better. So let's copy the same thing and make this one better. I'll copy this. This is 21.1 zip, and let's check it with our normal zip function. So we will compare this one we did here with the normal Python zip function, which is going to be the same thing we did. So time it zip, I'll pass in the f names and then the last names. Around it is going to be very fast, right? Because it's using a generator behind the scene. This is 21.1 microseconds. Hopefully this is going to be better. This is 1.2 microseconds, which is quite faster. So the reason it's faster is that it's using a generator. If I convert it to a list, it's almost going to be almost the same as the one above. So let's convert it to a list. We're converting to a list, and let's see what you have. Right, which is almost, this is even still, it is still fast, right? Very, very fast. So the reason is because it's using a generator behind the scene, right? Making it more optimized. So let's implement that generator option within our second option. So this is going to be the same thing we have done above, but this time we are trying to make it in the format of a generator. So let's see whether it's going to work. So how do we do that? So this is going to be method 2 using generator, right? We're using a generator format. So instead of this option that we have here, in which are using a for loop for the first one, we are going to use a generator option, right? So we can just go back to this, simply put, just take off this, right? We can just do it, this option here, take off this, and let's yield it. So we are yielding it, right? So let's see whether this is going to work. This is the simplest implementation of it, right? So I just go back, well, let me call it 2, and now let's run it with our example. There we have. So this is going to be my zip2. Let's see how fast this is going to be. And this is still going to work, right, like the previous one that we have. So in case you have any question or contribution, you can put inside the comment section below and let me know your opinion, or if you have any better way, or if what I'm doing I'm wrong. So this was 1.81, which is almost as close to this one, 1.2, and this is 1.81, right? Which is, yeah, we take it like that, which is a little bit close, right? Because we are using the yield, right? But we can actually, instead of using the for loop, we can actually convert the entire stuff into a simple one line, right? Which is also going to work, right? Without this long for loop. Very nice. So now I can just go back again and run it like this, combine it with 3. So let's combine it with 3 and see whether it's still going to work. Then I can convert it to a list in case I want to get the values. So this is failing. So let's see why it's failing. So because it is not defined, it is 2. Yeah, and it works perfectly well, right? Perfect. So our functions, our implementation is working as expected. So that's one of the ways of implementing or creating your own zip function. So first you get the minimum length, then you loop through them, right? Isolate, and then you loop through them, and then you pair them. That is something very simple. You can actually use all these functions you have done to unpack. So let's say I want to unpack this stuff we had here, which is 3 names. I want to unpack it. So let's put this one into, let's say, M. I want to unpack this M into this value. I want to unpack it. Let's see whether we can unpack. Unpacking using our stuff that we have, like unzipping, unpacking or unzipping. So in that case, it's going to be this option. So it's going to be my zip. So we have, say, the first name, last name, and salary is equal to my zip 2, right? Then asterisk, then M. Let's see whether it works. And it works. So if I go for F, I get all the first names. Perfect, it's working. If I go with L, I get all the last names, right? So you have seen how to implement your own zip in Python from scratch. So thank you for watching this tutorial. In case you have any question or contribution, you can put it in the comment section below and let me know your opinion, and let me see your own implementation. See you another time. Stay blessed. Bye.